12 o'clock again, and we've got Jenny back for another session, and it's going to be a CICS Performance update. So Jenny, if you're okay, can see your screen and everything. If you'd like to carry on with the presentation, I'll leave the room to you.
Thank you, Rob. Thank you. Thank you, everyone, and good afternoon. I'm Jenny He. I work in the CICS development since the first version 5 release, so 5.1 till now. So I've overseen 6 releases of CICS enhancement. So I'm very pleased and glad to have the privilege to talk you through the performance update, especially focusing on the most recent release as well as the past 2 releases before that, so 5.4 and the 5.5. Yeah, before I start my my next charts, so I like to go through the disclaimer, especially around the performance. So the figures, what you're going to see in these slides, it's based on the measurement and the projection using our IBM benchmark in a controlled environment. So I mean, controlled environment is the performance of CICS carry out. We're very much focusing on the CICS product performance without much of the application code running. So the figure you've got can be as a reference, but would definitely not be the actual figure you would get in your own environment, because you would have your own application code running on top of the CICS code. So, as the first thing I talked about, the CICS performance is how we measure the CICS product. We very much focus on the CICS product code. So the application, we deliberately make it very lightweight, which means we run very little business logic, but we make sure we drive the CICS particular area we want to performance test, make it particularly hard. So in that way, we would emphasize any change in any change of performance, which as a result of the CICS code change. So we have a dedicated LPA to run the automation. We run the automation overnight. There is no other workload running on the same LPA at that time. So it uses dedicated CPUs or the channels and or the DASD as a data store. And we measure it, we run with 5 intervals, and we record 5 RMF intervals over various transaction rates. But we would, for each transaction rate, we would run the transaction up to the steady level. Then we take a 5-minute measurement over that interval. Then after that, we move on to the next transaction rate. So we have the average CPU per transaction over those 5 intervals compared with whatever release we want to compare to, or whatever function we wanted to compare before and after. And we often give the transaction, we give the figure as a CPU per transaction to give an idea how much CPU is used. If there is any difference, particular hotspot we find in the CICS code doesn't perform well, we would use a hardware instrumentation to analyze those areas. So for each release of CICS, we would measure comparing with a previous one. So the first thing we would like to make sure is this release of CICS, whether it doesn't have any degradation over your customer's existing workload. So for the 5.6, which was GA'd in the middle of this year, we measured it on the hardware Z15 8561 with model T01. So that is has an LPA up to 32 dedicated CPs and 3 zips, and with other configuration, as you can see here. On the software level, we have ZOS 2.4. And if the workload involves DB2, we have the DB2 version 12 here. So we compare the version 5.6 at GA level and compare with the previous 5.5, and we had a refresh at December 2018 level of code. So let's see what we can see from the release to release comparison. So I'm going to show you two kinds of workload. The first one is, we call it a static routing workload. It's a mainly Kobo Jvm application. It represents a lot of our customers' existing application have run for many years in their work environment. So we think it's a good good application to make sure the CICS doesn't degrade any customer's application in this kind of traditional workload. Then the workload, it have 6 file control requests per transaction and spread across 69% of read and 10% of read for update, 9% of update, and 11 add, and 1% of delete. So we call it static. It's because the transactions are static, routed from two LRs, two TLR to two LR, then goes to function shipped to the FOR, then access the Jvm LSR. The workload is non-thread safe, and we drive through 3270 terminals from another LPA. So the measurement on the work which we're running would not be is not interfered. So looking at the figures we have measured, so we would so on the top row is a 5.5 release we have we measured as a comparison, and the lower row is a 5.6 release. And we the workload we drive, we can see the throughput is 7,203 transactions per second. That's very similar across these two releases. And we measured the CPU consumed for each type of region, the TLR, LR, and FOR. So the percentage showing here is a percentage of 1 CP for that particular TLR consumed. And you can see the total CPU across those 3 types of regions there. They are very similar between these two CICS release. And the CPU per transaction is expressed in millisecond per transaction. And the difference of them is really 1 microsecond. So which is even within the tolerable the measurement difference we can have. So we can conclude that for this type of workload, the 5.6 would not degrade any existing workload in this type. So next, I'm going to show you another type of workload, which is a Kobo Db2. It's a thread-safe application. It accesses Db2. So again, we drive through 3270 terminals with 500 simulated such kind of terminal. Looking at the 5.5 and the 5.6, for this type of workload, we drive the throughput up to 2,429, and for the 5.6, we drive it to very closely 2,433 transactions per second. And the total CPU consumed, they are very close, where it's really quite identical. So again, we are quite confident this kind of thread safe access Db2 workload, the 5.6 would not degrade the existing application. So next section, I'd like to move on to some specific areas of CICS and look at their performance. Those would be quite major functions in CICS, and also we enhanced them recently. So the first one is Java performance. In the CICS track, you probably have seen quite a few sessions on the Java. I'd like to give you a holistic view. Okay, so we got a lot of improvement on functionality, and we improved the application developers' experience. Now I'd like to show you on some aspects of how the Java perform in the CICS. So in the CICS 5.4 and also available in 5.3 with APA, we've changed the way of threading and the T8 TCB crate for Liberty and the JVM. So what happens now is now we have a pool of T8 TCBs that is ready to fire off once the Liberty get a request. So that T8 TCB, it doesn't have transaction ID, it doesn't have task ID, it doesn't have any security context, and it doesn't have any UOW context, but that T8 TCB is enough as run as in a Java code. So with that, we don't have to each time to tear down to return that T8 TCB to a pool. Instead, we make it the liberty to manage it so that it with this way, you get more zip eligible fractions for this kind of request. So with that, the transaction attach and detach for this type of request, now it happens on the T8 TCB instead of in the traditional way of QR TCB. So let's have a look how this improves the zip eligibility. So we compared the 5.3 with this APA enable this functionality, and we compare with 5.2 CICS. As you can see, the CPU per request in millisecond has reduced significantly from around 0.45 to 0.3, I would say 34. So it's quite a lot of decrease. And also the portion of eligible for offload to run on the zip, it's also increased in terms of the percentage wise. So I hope this is, so this is available in 5.3 or as a APA as well as upper level of CICS. So it's already in the 5.4, 5.5, and 5.6. So next few slides, I'd like to show you the multiple JVM servers. As you know, the CICS 5.4, 5.5, and 5.6, we improved a lot on the JVM, Liberty JVM server. So it's fine to run one JVM server to serve all your Liberty applications in it. However, we do can in CICS 5.5, we enabled multiple secured Liberty JVM server in a single CICS region. This is also available in 5.6 with the APA. So with that, you can get, if you spread across your Java application host on multiple JVM servers, maybe across different CICS regions, then you would get the achieve the high availability, or when one CICS region is down or one JVM is down, your application is still running in another instance. So we compared we looked at how the multiple secure Liberty JVM server performs, and we measured it on the 0S 2.3 with CICS 5.5 while it was in development. So we have here different kind of setup. The first is one region with one JVM, and the third bar and the fifth bar, they are multiple region, but each one with one JVM only. The second and the fourth bar is one region, but with multiple JVM Liberty server there. We're looking at the overall throughput we have here. So as you can see, the overall throughput, that's the number of requests per second across all the JVMs for all the setups. So as you can see, for the setup one JVM across on the one region, you get most requests so it has the highest throughput than other setup. This is because the JIT would optimize the code path because it has more requests going through that one JVM. Next, let's look at the CPU consumption. For the CPU consumption per request, so we can see the one JVM in one region has a better CPU usage than the other setup. So so across other setup, you would get a little bit high CPU cost per request. And also the orange bar show you how much is zip eligible and how much is would be running on the general CP. Then we look at the 31-bit of storage. So this chart shows you the total 31-bit of storage for different setup across all the regions and as a total for all the JVMs. For the first one, third, and the last one, which has one JVM on different region, as you can see, the usage of 31-bit of storage, they increased proportionally to because each region have only one JVM. So the amount of storage on the 31-bit, they accumulate because of that kind of setup. And for the multiple JVM in one region scenario, which is the second and the fourth bar, they have the slightly higher the CICS TCP storage, as well as the non-CICS TCP storage. So comparing to the one JVM in one region setup. So the CICS TCP storage usage, that is dependent on how many threads in each JVM you configure to. And the non-CICS TCP storage, that's because each JVM, they would have their separate runtime data to store on those places. So that's why they have a slightly higher than the one JVM in one region scenario. We have a similar story regarding to the 64-bit of storage for across different setup. So that gives you a view how the JVM Liberty excuse me, performs and how across, if you have set up across different JVMs and all across different regions, and also what is now the threading model from 5.4 is also changed. So from CICS wise, we have improved the CICS Java for the past 3 releases, and a lot of those improvements are backported to the previous CICS release as a continuous delivery APAS as well. So hopefully that gives you a more rounded view of how the CICS Java does and can offers for you and for your consideration as well. Okay, next section, I'd like to talk about thread-safe improvements in CICS. Thread-safe is not a new concept in CICS. However, CICS has been continuously improve what the thread-safe aspects. So firstly, let's look at what does thread-safe mean. So if you have an application which you have coded to a thread-safe standard, and your region one run with a SID parameter SDG PROTES, and that means storage protection, and your application may be making DB2 calls and running in user key. For this kind of application, how would you configure the program in order to maximize the time it spent on the OpenTCP? So here is a table for you to figure out how to maximize the time it can spend on the OpenTCP. So if you have an application on the OpenTCP instead of a QRTCP, so the OpenTCP are shown here are all the ones L8 and L9. So we have each CICS region will have multiple OpenTCP, but we have only one QRTCP. So that's why I would like the work run on multiple parallel those OpenTCPs instead of congested into one QRTCP. So with a thread safe configuration, you can run that kind of application to start it on the L8 or L9 TCP. And if it encounters a DB2 or MQ command, it can still stay on the L8 TCP. If you have concurrency required, this setup on the program definition. So if the application encountered a thread safe command, it will still stay on the L8 TCP, which means no change, no switch of the TCPs. But if it has a non-thread safe command encountered, the CICS will switch that particular period to a QRTCP. Then when that's finished, we'll come back to the L8 TCP. So the concurrency required, this attribute, we introduced it in CICS version 4.2. Prior to that, you would have the concurrency quasi reentrant or thread safe. With those configuration, with a quasi reentrant, it's the application primarily stay on the QRTCP. It only runs on L8 TCP when DB2 or MQ command is encountered. So with this table, I hope it can help you to figure out what your application will be run on with those different definitions of program definition and the seed parameters. If your program is a Java program, then it would be T8 TCP is used, or if your program is a CXP link program, it will be a X8 TCP being used. So let's give you some visualized view of those TCP switch. So here, the top one shows you at the CICS 4.1 time, we have some transient data commands which are not thread safe at that time. So so in 4.1, when that kind when that kind of command is encountered, it runs started on QRTCP. And the TCP switch will happen because there is a DB2 call, so run on L8 TCP. Then it will go back because the exact CICS write queue at that time was not thread safe. So those TCP switches can cause the response time and also the QRTCP time because of the majority of time running on QRTCP, so you will get less throughput because of that. With 4.2, we define it as a concurrency required. So with that, the application start on the L8 TCP. It only switched to a QRTCP for the period of write queue TD. Then it come back because we got this concurrency required definition there. Then in 5.1, we made the thread safe, the write queue TD thread safe. With that, for this kind of application, it always stay on the L8 TCP without needing the QRTCP when the application is running. So here we're showing you some measurement we have for those different scenarios for different configurations. So for the ones which are not thread safe and you need to switch to QR for majority of the time, it has 302 TCP switch, and the QR TCP was busy for 4.6 millisecond. And the second one is still need the TCP switching, but a lot of time now it's on the L8 TCP. So as you can see, the QRTCP now have much less time comparing to the 4.1 scenario. Then on the 5.1 scenario, then the time is all on the L8 TCP. So the dramatically reduced the TCP switch because of that. So here shows you a diagram with those measurements to show how many percentage of CPU is used with those transactions input. So the blue line here is for the CICS TS 4.1. And because the time it's needing on the QRTCB, so that limited the throughput roughly around 217 transactions per second in the setup we have here. Then for the 4.2 and 5.1, where we have the thread safe, so majority of the time are not running on the QRTCB, then the limitation of the transaction per second is not there. And the 5.1 have a slightly less of CPU used because of the TCP switches were much less. Okay, so that shows you how the benefit of thread safe, making applications thread safe. Then in 5.4, we provided a new set of asynchronous API command. So those 4 commands, run trans ID, fetch child, fetch any, and free child, they are a set of asynchronous API command to help you to write asynchronous way of programming much more easier. And also we made those are written to a thread safe standard, so you can use it in your application and run as a thread safe kind of application. We also have 2 other API command, transform data to JSON and transform JSON to data. These are the equivalent of data to XML transform, but it's just to a JSON. So those are also thread safe. 5.5, we have access to the coupling facility data table. We made it thread safe. So if you have file control commands which access CFDD data tables, then you would benefit from this version 5.5 and onwards. We've made all the sync point and all the other operations on the OpenTCB, which is the majority of the time your application will be run on, but the initial open and the load, they still occurs on the QRTCB, which we don't think is a priority as a congestion because of that. Also, we made the ExecKix query security we improved the number of TCP switches to the resource-only TCP. So if the application already running on the OpenTCB, this command will stay running on the OpenTCB without switch to the ROTCP. The last one is application from version 0.5 with this APA application running on the OpenTCB. It will stay on the OpenTCB if it uses auxiliary temporary storage. So again, it's saved TCP switching, which, as you can see from earlier chart, it would save the CPU. So I'd like to show you some of the performance figure we measured over the coupling facility data table, make it thread safe. So we have this workload. It has a mix of read only transaction and some update transaction, and we have some data table access with around 65 requests per transaction. Then we have those mix of read or read update or read write. So the first thing we did was to make sure the change we made for thread safe CFDT will not degrade any of your existing CFDT, which is non-thread safe workload. So the application we run on, we run this scenario and also the next one, which is a thread safe workload scenario. We run exactly the same code. It's just a changing of configuration. So with this one, as we can see, with the 5.4 and the 5.5, they are very close to each other. So we are quite confident that any of your existing CFDT, which is non-thread safe, are not degraded. So here we are showing you a CFDT threshold thread safe workload and what the CPU usage is like. For the 5.4 4, we have, as you can see, the number of the percentage of CPU per single CP is slightly less. However, it has a limit on the transactions per second. With the thread-safe CFDT, there is a much higher transaction per second you can get. So we can see the increase of 4 from around 2,500 up to 8,000 with this thread-safe workload. So at that point, we are doing 500,000 of file control requests per second with this thread-safe workload. Again, we also looked at the response time. So around the 1,800 transaction per second rate, non-thread safe of CFDT workload, the response time shooted up because of the need of user QRTCB. So there is a limit on how many transactions you can get through in that CICS region. But for the thread-safe CFDT workload, the response time steadily increased a little bit, and with the transaction rate up to 8,000 transactions per second. So if you look at the statistics, you can also see the evidence between the two CICS release, the running with this non-thread safe and thread safe CFDT workload. So as you can see in the red text here, the QRTCB, it accumulated 4 minute, 59 second, and 95 sub-second of the whole 5-minute measurement interval the stats interval we have. So that's around 99% of QRTCB. This QRTCB was busy during that time. While with the thread-safe configuration, the QRTCB was much less busy during that time. So hopefully that gives you the flavor of what the thread safe can bring you regarding the performance. And if your setup still got some non-thread safe, maybe you can look into how to make them thread safe and to benefit from those CPU savings and less response time. So next, I'd like to look at the CICS policy. As you know, the CICS policy, we enhanced a lot and have a lot of more choices for you as a system admin to control and monitor the system resources, the usage by CICS task as system rule or task rule. So with that, we looked at what's the performance if you were having those policy rules installed in your region. So here we have a very, I guess, unusual setup, which is our application is doing 1,000 of exact CICS assign command. So really it's trying to making sure the rules are exercised. So we define the rule on that kind of command. And also we installed 1,000 policy rules. We don't want to measure how much CPU is used when an action is triggered, because action can be a message or can be an event sending out to MQ or HTTP, or can be changing your WLM health level. So it depends what action you want to take. So we didn't measure that because that's varied, right? So we only measure the cost of monitoring. So imagine you have a number of rules running in your CICS region. They are all happily running monitoring. If there is any violation or you want to see message, it will the system will output according to the action you defined. So we wanted to measure the cost of monitoring here. We have run a transaction rate about 4,000 per second. And we looked at the overhead turning to having those rules monitoring the system. And we can see it's about 5 microsecond per transaction cost with this 1,000 commands installed there with 1,000 policy rules there. So it's really insignificant in regarding as overall in the, if you're having a CICS any application running. So we think with a policy installed in your region, it doesn't have much of performance impact. Okay, the next area I'd like to see is around the channel performance. In CICS version 5.5, we improved the performance for application where it use a lot of containers in one single channel. So by improve that, we internally CICS use a hash table to access those containers instead of going through a list. So what you would see regarding the application-wise from this change is when you use the exec get next container from a channel, the order of those containers are returned will be different. So which means if your application are relying on the order, then you may use this CICS feature toggle called com.ibm.cics.container.hash. You can set it to false. So the behavior of the CICS channel, the application using channels are the same as before. So we looked at the performance around the CPU per transaction. If the transaction have a very small number of containers, here is 10, then the performance they are very similar comparing to the before and the after. If your application has like 100 of containers, then we started to see the improvement of CPU using the performance, this improvement on the channel. The over 50% of improvement is observed if your application using 500 containers in the setup regarding the CPU. And also the response time wise, with this improvement, you can see we started, so with 10 containers in the channel, the response time with this with the change, it's a little bit very small increase on the CPU around the response time. But if you have 100 or more with that increase, you can see the response time decrease with this improvement. A next part around the channel improvement is Exci commands. So it started from 5.4. We introduced new Exci channel commands. And also in 5.5, we continuously enhanced that. So those new API commands for the Exci environment, you can use get container, put container, or move or delete, etc. So this is really enhancement to COM area, the way of using COM area. So previously, you could only use COM area, but with this you can use channels and you can send and more without a limit of virtually data into CICS through those channel and container commands. And with that, we enhance the DPL request, which is a new version 3 with a parameter list with those enhancements. And notice that you don't need to have your server on the 5 level or later. You only need your EXCI library, which run those EXCI applications, which on the 5.4 level, and it can talk to server on 3.1 or later. So this is a set of commands we put in 5.5 around the channel commands as well. So we compare the performance between using a COM area and using a single data array in the channel. And for the setup, we use the DPL request, so to compare for these two setup. First of all, we looked at the small payload performance. So small payload, we have the payload around up to 32 kilobytes here. So as you can see, the blue line, which is a COM area, it incurs smaller CPU per request. It's around 0.04 millisecond. So that's 40 microsecond less CPU for the request we've got. But for the larger payload, especially when the payload across the 64 kilobyte, you can see the significant of improvement on the CPU per request with the channel Exci commands. So for example, for the 2 megabyte of bytes, we transfer from the Exci into CICS, the CPU per request is reduced about 2 milliseconds. So that's really quite a lot of savings around that. Okay, so each CICS release, we would also introduce some new monitoring and statistics enhancements to help you to monitor the system and making sure it's making sure it uncover any problem it may have and making sure it's to use as a tool to cure it. So in 5.4 level, we introduced monitoring on how many rules this task has been actioned because it triggered some policy rules being applied to the task. We also provided, we call it previous transaction tracking information within the same region. So the transaction tracking is about if you were having 3 different regions, TOR, AOR, or FOR, we already have transaction tracking to see a task going from the TOR, then started another task in AOR and in FOR, use a previous transaction tracking information section in this tracking data. But in 5.4, we put in a previous transaction so that can see within a region this particular task started another task. So that is within a region. So with that, you can build you a more complete picture of how your application propagate from one region to next. We also put in monitoring on how many asynchronous APIs commands a task has made. So that is as a complete solution as we provide the asynchronous API commands. And also you can see the ELPA name in the CICS monitoring data. So accordingly, we enhance the statistics for the asynchronous APIs, how many have run in the system, and is any delay in the system because of the asynchronous API start child. We also put in statistics on the MQ monitor resource and enhanced the TCP/IP statistics, etc. So I mentioned the transaction tracking that it can, with this previous transaction information, it can help you build a more complete picture. So here it shows you 3 CICS regions. The first CICS region task, it used it has a DPL through a MRO connection to the second CICS region, started a task in the second CICS region, which this itself started another task in the same CICS region. So with the previous transaction data and the previous hop data, that can show you a complete picture how this whole application, what it does, why it does it. So right-hand side of this slide is enlarged a section to show you two different tasks. Both they have their association data, what the previous hop data will be like, what the previous transaction data will be like. So the task which is a parent task, it would have a previous transaction data 0, which means it is the top level. And the next one, it start in the same region, would have the previous transaction data 1. So that can give you a clue how these tasks are linked together, who started what. In 5.5, we enhanced monitoring on the SSL cipher, which is useful for the outbound request. And also we have the fields for the outbound web request on the receive, send, and invoke. As we have heard from Rob, yes, today's, which is around API, we see more evidence of the outbound request from CICS region are growing. So those kind of fields and the monitoring would give you idea how those outbound destination perform. I'll show you more on this next slide. On the statistics side, we have this new CICS policy statistics that can show you what policy rules are installed in the system, where they are, and what are the count, how many actions being taken for the rule. Then the last is a transaction event count. You can see for each transaction as a statistics now. So for the outbound request, we introduced new resource monitoring records for URI map and web service. So the resource monitoring record is really when one task, it has multiple outgoing destinations. So for example, if one application have multiple URI map to go to and to get the response back, then you can monitor using the resource monitoring records to monitor all these URI maps, how it perform, what's the open and the receive and the send, how long does it take, and what's the name, what's the cipher suite being used. So that's the same with web service. So with that, hope you can give you a more complete monitoring tool to see how the outbound traffic goes. Is any problem on one particular client? If there is, what solution you can get, whether you can use the asynchronous CICS API to fire out the request without waiting for the response to come back before you go on to the next step, for example. So hopefully those give you, from API level to monitoring level to statistic level, give you a better understanding and the solution suit your business need. For the version 5.6, we've improved the monitoring on the security, around the security. So now you can see the fields on the CICS performance class on how much time spent on verifying various tokens. The first are around all the passwordy tokens, and also on the basic authentication, Kerberos, and the Json web tokens. The next chunk of monitoring improvement is you can see how much time if a task has waited because of the MVS short-term storage happened. So that is the field, both one for 24-bit and another for 31-bit. And along that, we also improved the statistics around those areas. So we provided a new security domain statistics. With that, you can see how many authentication happened for different security tokens, what's the resource, how much command and the surrogate authorization happened in the region, how many were waiting, or how many are ongoing the request into the RACF, for example, and how many ACEs that created ICRX or doesn't need an ICRX. So it gives you a view how the security authorization and the surrogate those activity happens in the region. Is any congestions? And also we enhanced the user domain statistics. We added more statistic fields. For example, we added how many user instances were deleted because signed off, or because RACF notified CICS that the user instance were deleted. And also you can see how many user instance in the directory in timeout queue. So then you can, because that can impact the performance on the authentication user instance reuse, can impact on that. So just briefly to show you the MVS storage on the statistics, and to show you what it's like if you were looking at 5.6 statistics now. You can see a user region which is 24-bit and extended user region 31-bit, and it can tell you when that was sampled and whether the those 24-bit and 31-bit are they out SOS or they're not there. So the state, whether it's normal or out of storage condition, and how much are not allocated. What's highest level of unallocated, lowest level of unallocated. So whether it has been in SOS condition and how many tasks waited because of those SOS condition. Because with this statistics, right? So that's about all the performance improvement. Last section, I'd like you to point out the performance publications. In the CICS Knowledge Center in 5.4 or 5.6 of our Knowledge Center, we now putting all the performance report from the 5.1 up to 5.5 here. So a lot of contents, what you have seen earlier in this session, you can find more details in those particular release of performance report. You can find that in the section called Improve Performance. So there are lots of information in the CICS Knowledge Center. I myself use it a lot. I use the search function a lot, and I find it does good search and can find what I needed. So highly recommend. Also, we have some dedicated publications on certain features. For example, what's the CPU utilization of Java and EE application, web service performance report, and the JDBC driver, for etc. Then a latest one I'd like to point out is called the TRS 1.2 session ID caching for CICS in Sysplex. So this is a blog written by Ian Mitchell around in I think it was September, October time, to advise if you were using TRS 1.2 and using the session ID caching is certainly recommended in a Sysplex environment. So there are hyperlinks in those pages if you'd like to have a look. So the last one regarding the publication wise is blocks entries. So there is we have a new IBM Z and the Linux One community where we have a CICS session. So you can find a lot of blog entries here, which are the contents it's not that permanent, or it's some one-off article to show you how to use certain things and or introduce you certain features, which we don't see fit into the knowledge center. So we put it in the blog entry. So you can use the search function as well. Using this blog entry, you can find some older entries, which also old, but still being very useful if you are using that functionality. So those are the ones I I share with you today. So this session is for AX. Feel free to submit your feedback on this session. And the last but not least, we have this conference charity for you to, if you like to show your appreciation, to donate some to the charity, which we donate to NHS charity together. And thank you. Is any questions or discussions you would like to make?
Thank you so much, Jenny. There's nothing in the chat at the moment. I'm sure that CICS Performance is at the forefront of our minds at the moment, either certainly for my shop in the run up to Christmas, how people are going to spend their money. Oh, we've got a question from Andy. Hold on. Do you do performance testing using a standalone CICS region instead of the Tor AOR or FOR setup? So
it really depends on the scenario we want to test. And so for the first one, the static routing, if I move my slides to the first one, we have this release to release comparison here. For this one, we have a setup from TOR to AOR to FOR, so that is not a standard region. We also have a standalone CICS region, which is next one. It's a DS, no, not this one, but with the RTW one. That one, it is a standalone measurement for this particular setup. We also test over multiple region setup as well, but I'm just not putting that measurement every combinations of workload measurement we did here. So we do a standalone region as well as multi-region. So it really depends on the what's a scenario we want to test.
Yeah. Okay. So I take from that these aren't the only scenarios that you test, Jenny, when you're doing a testing of a release. So Andy, I hope that answers your question.
These are the ones I'm showing. For others, we have very similar results. But as I said, in the CICS Knowledge Center, in that performance report, you can see more other scenarios and setups we tested. So feel free to pop to the Knowledge Center to have a look in more details for other setups.
Okay, and Andy's acknowledging. Thank you.
Thank you.
So excellent. Yeah. So as I was saying, I guess performance is on the forefront of our minds in the run up to Christmas, certainly with the UK financials, and I guess post lockdown we'll be keeping an eye out on any new workload or floods or a huge amount of online banking occurring or payments to Amazon, etc.
With this moving to more online shopping behavior, I'm sure it's getting more busier.
For sure. But thank you very much for another excellent presentation, Jenny.
Thank you.
Thank you everyone for attending. We're back at 1:30 with an internals presentation from Ezra Gross. So I'll close the meeting. Thank you very much for your attendance, everyone.
Thank you.
Thank you, Jenny. Bye-bye.